Hi, my name is Kyla Hagan, and this is my DSARI project for BBE 2201, in which I performed an energy audit on the research lab I work in on campus. I work in the Lang Lab in the Cancer and Cardiovascular Research Building on the University of Minnesota's East Bank campus. For my energy audit, I measured 18 instruments. Some of these were the same type of instrument but different models. I was curious if one of the models would end up being more energy efficient than the other. To measure variable power for instruments such as the computer, fridge, and freezer, I plugged the appliance into the kilowatt meter for over 24 hours, then used the calculation shown. To measure constant power for the remaining instruments, I measured each device in 3 modes: when it was plugged in and off to measure phantom power, when the device was on but not in use, and when the device was running and in use. To measure the energy use per day for lighting, I used the wattage provided on the bulb and multiplied this by the hours the bulb was on each day. In retrospect, I probably could have and should have used the 24-hour method for all of the devices, but frankly I just didn't have time for that. It also wouldn't provide an accurate example of time that each device was used, as it varies from day to day depending on the experiments being performed. While I did measure phantom energy, no devices that spent any time off used any phantom energy, so it did not factor into total energy consumption. I met with my lab in order to get an estimate of how much time each instrument was used each day. A logbook didn't really make sense in this case because our use of devices depends on what experiments are being done each day or each week, so we estimated some average times instead. The total energy use per week was scaled based on how many days per week the instrument was in use and how many instruments of that model we use in the lab. From that, the average energy use per day was determined, and the cost of electricity per year was estimated, assuming the average cost of commercial energy in Minneapolis is $0.0873 per kilowatt hour. I did not include the old rocker in this table because we don't use it that often anymore, so it doesn't factor into weekly energy use. The fridge, freezer, and computer were the biggest energy users out of all the instruments measured. When in use, the new rocker used 1.2 fewer watts than the old rocker. The belly dancer surprisingly used much more energy than either of the rockers, about 4 times as much. This device is very old, so replacing the belly dancer with a new model would be a smart move to save some energy. Again, there was no big difference between the old and new models. The TC centrifuge, though very old, consumed much less energy than the other two, likely because it is not refrigerated like the other two. All 3 centrifuges take up a lot of energy while on and when in use. They should be turned off when possible in order to save energy. The new microscope uses a screen to show the samples, but if the screen were omitted and it were used just with the eyepiece, it would use almost 1/2 as much energy as the old model. The PCR machine consumes a lot of energy from the light bulb alone. It likely consumes much more given the whole machine, but I was unable to measure its consumption as I did not want to compromise any data. This is a diagram that shows how much energy each category of instruments uses each day in comparison to total energy use. Computing, which consisted of our computers and laptops, used the most at 35% of daily energy use. Summing the average energy use per day for all devices, the total energy use per day in my lab is 11.34 kilowatt hours, only including the instruments I measured. The monthly and yearly energy totals were also calculated. So how does my lab's energy use compare to other facilities? According to a 2012 study by U.S. Energy Information Administration, an educational building will use 345,000 kilowatt hours of electricity per year. My lab uses roughly 4,000 kilowatt hours yearly. With approximately 54 labs in our building, the CCRB will use about 225,000 kilowatt hours per year. This equates to an energy use of almost 65% of the average educational building. Why is this percent so low? It could be that we actually use less energy than the average educational building, which is entirely possible. It is also likely that not all of the big energy users were measured. Many devices could not be measured due to the outlets being inaccessible or due to concerns of jeopardizing the equipment itself. Some big energy users that I could not measure include the -80 freezer, a spectrophotometer, PCR thermocycler, incubators, and hoods. California Institute of Technology and Harvard University both perform studies of research labs on their campuses, measuring the amount of energy the labs use. Comparing my lab's energy use to theirs, on average we use less energy for the big appliances and use more energy for the smaller appliances. The discrepancy in freezers could be due to the fact that I did not measure the energy consumption of -80 freezers. I included incubators on the chart to show how much energy they consume, contributing to the conclusion that I likely did not measure many of the heavy energy-consuming devices. So what can we conclude from all of this information? Research labs consume a lot of energy. My lab alone uses a little over 11 kilowatt hours daily, equating to over 4,000 kilowatt hours every year. That is already at 65% of the average energy use for educational buildings without taking into account the many big energy-consuming devices that were not measured in my audit. So how do we work towards reducing our energy consumption? One way is to get lab members involved. Remind them of the amount of energy it requires to use equipment and request members to implement energy-saving practices. We should also turn off the computer more often. It takes up the largest percent of our total energy use, and that could easily be decreased by turning off the computer at night. That could result in 60% savings for the computer alone. We could also invest in updated energy-efficient equipment, though that might not be in our budget. I also didn't notice a huge difference in energy consumption between old and new models of the instruments. It would probably be more effective to turn off the instruments when they are not in use. Our lab does have motion-sensing lights, but it would save energy to just use natural daylight during the day and opt for overhead lights when the daylight is insufficient. We can easily reduce our energy consumption by simply making an effort to be more aware and conscious of our energy use. These are my references. Thanks for listening.